Okay, chapter 10 is all about circles. So we're going to start off with some basic vocabulary here about parts of a circle. So a circle is the set of all points in a plane that are equidistant from a given point. Okay, maybe. Set of all points in a plane that are equidistant from a given point. Okay, the next one is center. It's the point in a circle that every point on the circle is equidistant from. Okay, the next one is radius. It is a segment whose endpoints are the center and any point on a circle. Okay, a chord is a segment whose endpoints are on a circle. A diameter is a chord that contains the center of a circle Okay, a secant is a line that intersects a circle in exactly 1 point. A tangent is a line in a plane of a circle that intersects Oh, you know what? Hold on. Sorry. I messed up. I was reading a different one. I thought something sounded weird. Okay, so secant is a line that intersects a circle in 2 points. I need to pay attention to what I'm writing. Sorry. In this one should be 2 points. Secant, 2 points. A tangent is a line in a plane in a circle that intersects a circle in exactly 1 point. There we go. Okay, so then the point of tangency is that 1 point. So it's the point, a tangent line intersects a circle. So tangent is 1, secant is 2. Sorry about that. Okay, so then I'm going to come down here. I waited to the very end to do this. Okay, so we're just going to go ahead and fill in all of these things. So I'm going to start at the top and just work my way down. So the circle and center kind of go together. So we're going to put the center in here and we're going to label it P. Okay, so over here to the side, the way that we would name this, that is how we read this, is circle P. Okay, so if you're naming a circle, you put a circle with a dot in the middle, and then you put whatever name they name the center. Okay, so then this is also obviously the center. So let's label that. Okay, a radius is from the center out to the edge of the circle. So this is a radius. A chord is just from one side to another of the circle. So it can be really anywhere as long as it touches both ends on the circle. Okay, a diameter though is a special chord that goes through the center. Okay, so make sure you get your center in there. Goes all the way across, so that is a diameter. Okay, the next one is a secant that goes through twice. Okay, so a secant is actually a line. Okay, so make sure here you have lines. Okay, so here you have lines and here you have segments. Okay, so there is a difference. So a secant is going to continue through, and you need arrows on a secant. Okay. And then the next one is a tangent. Okay, it's also a line, so it's going to have arrows, but it only touches the circle in one point, which this one's kind of hard to show that because that circle is so thick. But do your best. Okay, so there's my 1 point. So this is a tangent line, and this point is the point of tangency. Okay, so that is everything that you need for that front page. Okay, turn the page. Okay, example 1, identifying special segments and lines. It says, tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of circle C. Okay, so part A says segment AC. So A to C, that would be a radius. And it's a radius because if you want to go ahead and fill this all in, I'm going to leave it out just to save myself some room. But it's a radius because it has an endpoint at the center and on the edge. Okay. Part B is segment AB, A to B. That is a diameter. Again, if you want to fill this in, you can, because it has endpoints on both, both endpoints are on the circle and it passes through the center C. Part C is ray DE. So ray DE. So from D all the way to E would be a tangent ray, because you can go ahead and fill this in because it only touches the circle in exactly one place. And D, line AE is a secant because it touches the circle in two places. Okay, so if you want to put those reasons in why, that would be good for your notes. Okay, the next one is a coplanar circles and common tangents. So in a plane, two circles can intersect in 2 points, 1 point, or no point. Okay, so tangent circles are coplanar circles that intersect in 1 point. Concentric circles are coplanar circles that have a common center. Common tangent is a line or segment that is tangent to two coplanar circles. Common internal tangent Okay, it intersects the segment that joins the centers of the two circles. Okay, common external tangent does not intersect the segment that joins the centers of the two circles. Okay, so let's look at this actually in terms of a problem here. So it says tell how many common tangents the circles have and then draw them. Use blue to indicate common external tangents and red to indicate common internal tangents. Okay, so we're going to draw in some tangent lines here and then we're going to figure out if they are common internal or common external tangents. Okay, so what a tangent means is that it just touches that circle in one place. So I have a tangent here. Okay, first we're just gonna fill these all in. Then I see another one out here. Okay, do your best to draw a straight line. I see another one right here. And another one going the same thing but this direction. Okay, then I want you to connect the two centers. Okay, so a common internal tangent it says it does intersect the segment that joins the centers of the two circles. So internal is if it touches that line. So I see two tangents that touch that. So I have two internal tangents. And I have two external, because I have two that do not touch, making four total tangents. Okay. All right, so on this one, okay, I have a tangent here. And I have a tangent. Ooh, this one, sorry, I started that one off bad. I have this tangent and I have this tangent. Okay, connect the centers. In all, I have three tangents. One of those is internal because it crosses that line, and two then are external. Okay. Then on part C, I have a tangent here and a tangent here. Okay. Connect the centers. I have two tangents total, and two of those are external. Okay. Turn the page. Okay, using properties of tangents. So theorem 10.1, tangent line to a circle theorem. So it says in a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. Okay, so over here on this picture, we have line M is tangent to circle Q if and only if M, the line M here, is perpendicular to segment QP. Okay, theorem 10.2, external tangent congruence theorem. So it says tangent segments from a common external point are congruent. Okay, so if you can see this circle over here, okay, both of these are tangent because it only touches in one place. They are congruent, okay? So if they are both tangent segments, then they are congruent. So it says verifying a tangent to a circle. So in example 3, it says, is segment ST tangent to circle P? So if it was tangent, okay, ST touches this radius, okay, if we want to know if this really exists, that would see if I have a right triangle or not. So does 12 squared plus 35 squared, does that really equal, I do want an equal sign, not a box, sorry, does that really equal with question mark 37 squared? Okay, I get 144 plus 1225. Does that really equal 1369? Well, yep, it is 1369 equals 1369. So yes, segment ST is tangent to circle P because triangle PTS is a right triangle and ST is perpendicular to TP. So segment ST is perpendicular to the radius of circle P at its endpoint on circle P. Okay. There's that. Example 4, in the diagram, point B is a point of tangency. Find the radius R of circle C. So you know that this is a tangent line. So you know that this right angle here has to exist. Okay, so then I'm going to figure out what R is. So I have R squared plus the other leg is 80 squared equals, okay, this whole hypotenuse though is not just 50, right? That wouldn't make sense because it has to be the longest side. So it's actually 50 plus R squared. Okay, so I get R squared plus 6,400 equals, okay, now whenever we take this, okay, this is a good introduction to what we are about to do in algebra 2. So 50 plus R squared is the same thing as 50 plus R times 50 plus R. When you write it twice like that, you do not just multiply 50 times 50 and R times R. That will not give you the right answer. You have to FOIL, okay, or use a distributive property. So 50 times 50 is 2,500. 50 times R is 50R. Then another R times 50 is 50R, and then R squared. Okay, so you get R squared plus 100R plus 2,500. Okay, the R squares are going to cancel because they're both positive. Okay, so then I get 100R plus 2,500 equals 6,400. Subtract the 2,500 and you get 100R is equal to 3,900. Divide by 100 and you get 100 is equal to R. Or sorry, not 100, divided by 100. 39 is equal to R. I'll just rewrite it. There we go. Okay. Example 5. Last one. Yep. Okay, so it says RS is tangent to circle C at S and RT is tangent to circle C at T. Find the value of X. Okay, so it's saying that RS and RT are tangents, so you know that they are congruent to each other. So 28 is equal to 3x plus 4. Subtract 4, you get 24 is equal to 3x. Divide by 3, 8 is equal to x. And you are done. Yes, that's right. My notes are wrong. Okay, if you have any questions, please let me know, but that is all that you need to do your assignment tonight.